Hello and welcome to another Bevy video. In this video, I'm going to be showing you the updates that I've made to my Bevy Sprite animation plugin. So I'm updating it to 0.4 of the plugin, which is to coincide with the update of Bevy to 0.11. So I did a video the other week on Bevy states and I mentioned this plugin. I wrote this thing over a year ago and I've learnt a lot since then. So I went through and I implemented a lot of my learnings and made a little change log and everything that I'm going to just go through just to give people an idea. The official release of 0.4 of my plugin won't happen until next week because I want to give people a chance to put input in what they think I should change before I release it. And I'm going to actually release it on crates.io this time. So it should be easier for people to get and use without having to go to my GitHub. If you'd like to give the plugin a try before it gets officially released, you can find the v0.4 branch on my GitHub linked in the description. This will give you access to the most up-to-date version that you can then put issues and pull requests and stuff on to have them implemented into the final crates release. So the plugin lets you make sprite animations using like a tree node approach. So this particular plugin is to demonstrate that. So the zombie will stand in idle. If I press left and right, it will switch which way the zombie is facing. If I then press up, the zombie will start walking. I can still flip directions. The animation is controlled by setting an enum, which will then change which animation is chosen. And then I can press up again to go to running. And then I've got actual game logic that prevents me from flipping while in the running state. But where the plugin becomes really useful is I've got little script nodes running. That means if I pressed down, he will fall over. And if I press up, he'll stand up. And he actually tells the Bevy application to change his state when he finishes falling to that he's laying down, and when he's finished standing, that he's standing up. So that this means that if I press down and then up, he doesn't actually get to stand back up until he's all the way down. But if I flip in the other direction because it's easier to see, if he falls forward and then I press up and then down again, he will actually fall while falling down. That is controlled by direct Bevy code that basically says if he's in the standing state, he can transition. But you'll notice he actually resumes his falling state from the position that he's in the stand-up animation. So the further I let him stand up, the further into the falling animation, or like less into the falling animation he is. And this is also done with this by calculating where it should be, which means that the game can actually correspondingly react to how far through an animation you are to determine logic without necessarily having to track that all yourself. The other thing that the plugin lets you do is, which I don't have in this example, is if you were to shoot like a gun, you can set events on certain frames if you wanted to, so that it could set the state's value for like play the gun sound effect or play a stepping sound effect in like the walking animation. Oh, I'm going to stand back up. If I get him to walk, I could have it so that every time it reaches a specific frame, it sends an event saying like play this sound now sort of thing. I hesitate to call them events. They're more like you can set something in the state that something in Bevy will then read. So yeah, that's basically all the things. I also added, because someone requested it, a scaling node, which means that like when you press space or an attack, the actual animation speed changes throughout the attack, and supposedly it's to let you do emphasis on certain things. Don't know if it's working quite right, because I feel like sometimes depending on what frame you start on means that it may just skip certain frames because of how it calculates how much to progress the frame. But that's up to people that use it, I guess. You can implement your own nodes fairly easily if you want to actually have custom behavior. Another thing I forgot to mention that's really important for like specifically why you would use this kind of animation system is that each node can use its own index, which means that you can do things like having the walking animation know which foot's forward, left or right, or like a specific index into the animation that is moving. And then when you do things like walk to run, you can then make the running animation start so many frames into the running animation based on the walking animation. But things like the attack always starts from 0 because they actually use different indexes. So the walk cycle can be halfway through and you swap to running and it'll swap to the running halfway through, whereas attack always starts from the beginning. And that's one of the primary uses of custom indexes, which I forgot to mention when I originally recorded this. And another thing is you can set things temporary. So the walking and running may use a constant index. This means that, you know, when you resume running again, they will resume back to the same point, whereas attack can be a temporary index, which means that if you don't set it the previous frame, it will reset back to 0. So if you interrupt an attack, it'll restart the attack from the beginning, whereas if you interrupt the walk-run cycle, it will just resume back to wherever in the walk and run cycle it was. Or a better example would be the idle animation. If your character does something specific in their idle animation and you start walking and then you go back to idling, they will go back to idling at the same point unless you say that their idle animation is temporary. So the biggest change that's come is that node IDs are now an enum. Originally, they were a new type of U64, and I would hash the name of a node in order to generate its custom ID and just assume that names wouldn't overlap. And then when you requested it, you'd have to hash the name yourself to get the corresponding ID. So now instead, I have a handle which can point to a Bevy handle of animation nodes. This will become important when we talk about the SERD section. Then I've got a name which has a copy on write string that lasts as long as the node ID. This is so that if you have a named node and you request its ID, it can return its name, which is really useful for debugging purposes, but it also keeps a hash. So if you were to then clone that name or call the function to static to turn it to a static lifetime, it will take that hash and return a hash version of itself. Originally, I didn't have it keeping this hash, but I figured it was better for you to generate the hash when you're like requesting an ID than when you try and clone or copy the ID. So instead, it just copies the ID, and it means that in our partial equal code, wherever that is, in our partial equal, we consider names to compare the ID. So theoretically, you could have hash collisions and have two names that are different, have the same ID, but it also means that the hash variant and the name variant compare these IDs and will return based on that, not the actual name of the node itself. And this is another reason to keep a hashed version in the name is rather than hashing it every time you compare, it only gets hashed when it first gets created. So yeah, and then we have a U64 version. This is for what I originally called ID'd nodes as opposed to named nodes. So if you were to say like this node has a name, but it's actually got the ID of 1 or 0. It made writing node trees, which is the asset type. It made writing these much easier because you could just say ID 7, and then down here, when you create the index node, zombie 1 fall, and then you could say it's ID 7. If you don't give it an ID, its ID will be name zombie 47. And in theory, you could also say that it links, instead of to an ID, it could link to a named ID. So if you put name here instead and then this string, it would link to it. And you could also put the hashed value of this string. I use Ron's deserialize any, and it detects if there's a quote mark at the beginning. And if there is, it'll deserialize it as an actual string name. Otherwise, it'll pretend that it's a hash and try and deserialize it as a number. This lets static named nodes be serialized even if you don't actually have the name anymore. So it was just a way of allowing for certain types of serialization to take place. I did the same thing with attributes. Originally, I wasn't going to. Attributes work the same way. They were a new type U64, and I had rules like numbers less than 256 were considered core attributes, which gave me 256 values that I could set for things like delta, frames, flip X and flip Y, things that I had custom code written to take care of that you may need to use in your nodes or whatnot, but didn't want other people to necessarily like. If you needed to know that you wanted to indicate to a future node that it could flip the X and Y, you would use one of the core ones because otherwise you'd have to know every other node's combinations. So I used these for. I've decided to instead make this an attribute. It does the same thing with custom. Customs work just like the node IDs. You can specify a name for it, but it also keeps a hash, and when you clone it, it'll actually return the hash value. So for debugging purposes, I can print names, but when I start moving them around, you immediately hash it, or you start passing around the hashed version, and it doesn't have a big memory overhead or computational overhead. Same thing is there's now index nodes. Originally, I had anything less than the max U16 was considered an index and was only allowed to store a U size as its attribute. But now that they're their own actual variant, and they do the same thing where you can have a name for them, which means that you can, in theory, have custom attributes and custom indexes with the same name because they are actually stored in a different type. and they do the same thing. And with that came the attribute helpers. So state now stores a boxed dynamic reference to a state object, which is just something that implements reflect. So it needs to have reflect, send, sync, and any, which I believe is also covered by reflect. So it's a bit redundant. And it needs to get, at least for it to be automatically implemented, it needs to get type reflect, or get type reflection, which I'm not entirely sure how that works. It should implement for anything that implements reflect, basically, because I'm pretty sure this is automatically implemented by reflect. And then the idea is that it holds a dynamic boxed reference to that, rather than the original version would serialize it into bytes and then deserialize it into bytes. And the main reason I was doing that originally was it meant that you could use script nodes and override the bytes, like if you knew what the value was. Now it actually just holds a reference to the value, and using any, I can know what type that value is. So in theory, the limitation of this is you need to know exactly what type you're requesting. So things like requesting a U16 when it's actually a U32 won't work. I believe in the old version that would have worked, because I was just deserializing the value, which meant that it would look at it and go, oh, a U64, but it's actually a U16, but I can deserialize a U16 into a U64. Now they need to be exactly the right type. I might in the future add some kind of method that lets them convert, but not really experienced enough with Rust to do that. You can set attributes as any type now, so it just basically removes the need to be able to serialize. There's also index helpers, which, again, they know exactly what type they should be, and therefore can do other things like asserting that the type's correct and unwrapping and returning 0 if you request an index that's got the wrong type. And it'll check also that the index is correct. So if you request something that's not an index, it'll just return none immediately. Otherwise, it'll return 0 or the index. So it lets code be more aggressive when checking indexes. It doesn't need to unwrap things itself. This is the fun part. I've moved loading of nodes into the asset server. So now instead of needing to register custom loaders and things onto the asset loader, you just register them as reflect, like you would any other type. So register reflect, and as long as they reflect deserialize, my code will attempt to grab that reflection code. When it goes to load it, it'll go, hey, do you reflect deserialize? Here's your data. And it will pass it all the data inside the load node. So it uses this piece of information to request the type, deserialization code, and then we'll pass all the information between the parentheses. So in theory, this would allow for non-RON loading, so I could have just binary data between the parentheses. I've added a trait called LoadNoad, and LoadNoad has a function load, which you get given a string, the load context, and the dependencies. And with that, you can come up with a function that will then load. And so if you reflect LoadNode, when you create a node, we'll go to a FPS node, it reflects LoadNode. And because it reflects LoadNode, I can call load on it, which just calls RON deserialize. So because you specify how you turn a string into a node, if you want to embed your node so that they serialize to binary, you could do that because you were actually just passed this as a string. You could then remove the parentheses from either end, read it as hex, as binary, as whatever values you want, and deserialize it however you want. So as long as you return an animation node. I have got things written on the load node here that say things like, you can use the context for getting strong handles and loading sub assets and other nodes, but your root node must be returned, because otherwise the way that I load nodes, Bevy will just immediately unload the asset as soon as it returns. So if we jump over, or I guess scroll up to 30, when I load a node, we load them all as trees, even if you use node or node tree. I just allows me to check to see if it's formatted correctly. Originally, I was using .nodes would be inserted at the handle ID, but I figured that would be annoying if you specified it to have a specific ID. And then it went, oh no, I've overwritten that. So instead, all nodes loaded by the asset server are loaded into what's called a reference node. And a reference node is just a node that holds strong handles so that they don't unload all the subnodes as soon as you finish loading them, because they're loaded with custom IDs. And then, so the reference node holds that. It also holds a path to the loaded for debugging purposes. I could probably get rid of that and replace it with an asset server lookup, but for now it holds a path. We then basically go through and check each file, and we first check to see if a custom ID is specified, and then we load the node. We then set that node's ID to being the custom ID if it has one. Otherwise, we just use the node's actual ID. We generate a strong handle for that ID, because all IDs get turned into handles which have different UUIDs depending if they're using a ID or a name for their path, but then use the 64-bit hash for the actual handle identifier. We then send a LoadNoad command, which just like later on at the end of the frame or at the beginning of the next frame will load that frame into the assets, allowing for your node to be accessed through its specified ID rather than having to use weird handle integration. And then we just sort of trim away the extra data and loop. Then we insert the node, the reference node, and we set with dependencies. This means that things like index nodes can be saved, if we go up here, with the actual paths to the image rather than handles that you need to load the image independently. So we basically just call these as dependencies, and then Bevy will go through when it loads a node and go, oh, you've got all these dependencies, and it'll load those dependencies as well on top. So it means that I don't actually have to custom load the images and then request strong handles. I can just load the images using the assets themselves. I cleaned up the animation node trait. So now there's only 4 of these that are actually mandatory, maybe even less. So run, you need to say how your node runs, which, for example, the reference node will just return the first node in the list. This can return a node result, which is the next node to run or the image to set. And then a run error, which is, I believe at this point, just a string. No, run error has got a bunch of different types, isn't it? A state error or a custom string. So this could expand in the future, but basically you just allows you to return what error you got, and that error will be printed. The name by default will return the short name of the type, but you can specify this to be whatever you want. So for example, the FPS node and all my custom nodes have names that you can call the node whatever you want. You can set an ID, or you can request the ID, which is up to the user to decide how they do, and you can set an ID, which is up to the user. So for all my custom nodes, they have an option ID. So if you never call set ID, they return a name variant of their own name. If you do call set ID, they will return that ID instead. This means that if you, say, have your zombie FPS node and override it to be ID 1, even when you call it and request for its ID, it'll tell you it's ID 1 because you've overridden it. I've got serialize, which is auto-implemented, just to say that this node doesn't implement serialize. I haven't finished implementing serialize yet, so it's all a bit broken. And debug, which will just write the animation node and its name unless you override it with your custom node's logic. And a dot file, which also just inserts the node and its label into the dot graph when you go to render it. We'll talk about the dot graph in a minute. The set ID, which just lets you control things. And I've cleaned up all the errors. So originally, I had just a ridiculously long, every variant of error was all just in this struct. Now you've got run errors, which are returned when you have an issue at runtime, state errors, which are returned when you request or do something with the state and it doesn't work. A save error is going to be returned when you serialize something, and the load error will return when you try to load something. So all these errors are then able to be handled by you if you are using the crate externally, but they're like sort of broken down into the region of the crate that you're using. And some of them, like serialize, are behind references. Okay, and I think the final thing I want to talk about is the dot graph. At the moment, it's a bit simplistic because I really don't know how to configure a dot graph properly. But if you type in dot and then hit plus on the numpad, it will bring up a dot graph, which represents all the information inside your node tree. So the way this works is it actually iterates through every entity that has a start node attached to it and every node in the assets tree. So entity 2, which is the zombie here, points to the test node reference node because it got its node directly from the asset server loading the test.node file. That node's first node is the zombie FPS node, so it points through that and immediately runs that node. This node will then run the switch node, and then based on its output, or what values it's switching on, will determine, whether it runs end fall, forwards, backwards, stop standing up, stop attacking. These are all scripts, or it might run the zombie running, the walk scaling node, the zombie attack, and all that, these fancy nodes. And then each of these nodes, if they're colored green, are the actual image that's being set. So zombie 1 is from the idler, and then the attack will set, and the fall will set different nodes. The dotted lines mean that the file, so for example, the zombie node tree, is loading them, so that it's just holding them open, whereas the solid line from it is the first node. So if you were to point an entity into this node tree, it would call stop stand up F, which is probably not the correct thing to load, but it is the first thing in the file. So if I wanted to default to, say, the switch node immediately without setting the FPS, you would then just use, you'd make the switch node the first node in the file. The red lines are sort of error states. So, for example, the script nodes have what's called a fallback node, which is if the script at any point runs into an error trying to read itself or run, it will just return to its fallback node. So all the scripts will fall back to zombie idle. Thank you for making it to the end of the video. I'd like to thank my patrons for supporting my channel. If you'd like to become a patron, the link can be found in the description, along with a link to the Bevy Sprite animation plugin, and also my previous video that actually goes through the examples and sort of shows how to run. Obviously, some things have changed with the new update, but you should be able to look at the compiler errors or compare the new up-to-date examples with the examples in those videos to see what's changed. Again, feel free to suggest anything you want to see seen in the official release, and I will hopefully get it added. So thank you, and I will see you in the next video.